So obviously on the midterm we're going to have a lot of systems of equations. Okay, systems. That was the first thing we did in this second semester. So we did systems of by substitution method. We solved systems with elimination method, substitution, and also by graphing. And all three methods will pop out on the midterm exam. So on number one, that's an example of substitution. So what we're going to do is simply take the equation that has y by itself, and we're going to plug in y into the other equation. Hopefully this all comes back to you here. So we're going to take this and we're going to plug it in to the y value, because that's what y equals. We're going to plug it into the y value of the other equation. So I like to draw arrows when I substitute. Okay? And then I'm going to rewrite my new equation over here on the side. So my new equation will be 3x plus y, but instead of y, I'm going to put the parentheses, equals -9. So inside of the parentheses, I am plugging in the 2x plus 1. Now, if we look at what's on the outside of the parentheses, there's a plus sign. And if I distribute that plus sign, nothing changes. So I could just rewrite everything without the parentheses. So I'm going to rewrite it in blue. Our new equation that we need to solve is going to be 3x plus 2x plus 1 equals -9. So we need to solve. Let's get the, let's combine like terms. How about we combine the x's with the x's? So 3x plus 2x, we already know that that's 5x. Let me rewrite everything. Plus 1 equals -9. And then let's solve this thing by getting x by itself. So of course, you want to get rid of the 1 first and then get rid of the multiplication of 5. So let's get rid of that 1 by subtracting 1, subtracting 1. We're going to have a new equation that reads 5x equals -10. And our final step would be to get rid of that multiplication of 5 in front of the x. That really says 5 times x. To get rid of it, we're going to do the opposite of multiplying, which is dividing. So our final answer is x equals -2. Now that's barely one answer of the system. And your system has two variables. So you already have the x, you need the y. On any equation that you have an x and you need the y, you simply plug in x and you solve for y. And it doesn't matter which one you plug it into. So which one would you guys prefer, top or bottom? Top. Okay, so on the top it does say y equals 2x. I'm going to put parentheses instead of the x, plus 1. Okay, so because the x value equals -2, I'm going to take that -2 and I'm going to plug it in right there. So it's going to be -2 right in there. And we all know that 2 times -2 is -4. And of course, we still have the plus 1. So -4 plus 1, you're going to have y equaling -3. So your answer to number 1, to the system, I forgot if they wrote the multiple choice answer as a coordinate or if they actually wrote it as x equals -2, y equals -3. I think they wrote it as a coordinate. So I'm going to write the answer as a coordinate. -2 for x and -3 for y. Now, of course, if you have some extra time, because there's only like 21 questions on the midterm, maybe 20, I'm not sure. I think it's 21. But you're going to have plenty of time to do these 21 questions. If you have extra time, plug in your x and your y value into both equations and make sure that they work for both. That way you could double check it and make sure that you're absolutely positive that both answers work. That way you get that one right. Number 2, it's also a system, but we're not going to use substitution. This system's really easy because it's set up for elimination method. So check it out. I am going to, why do I say it's set up for elimination method? Because if I combine the lines, the 5 plus 3 is 8m. Right here, the -2p and the positive 2p, that really cancels out. So it's ready to rock. It's ready to go. So you're going to have one of these on the test. It's pretty easy. So let's combine the lines. We said 5 plus 3 is 8. We have an m. The -2 plus the positive 2 cancels out, so they disappear. That's why it's called elimination method. They eliminate. Equals 24 plus 24 is 48. So we have a simple blue equation here that says 8m equals 48. So we need to solve that simple equation of 8 times m equals 48. We're going to divide by 8. Divide by 8. M equals 6. So m equals 6. That's one answer. You still need the other answer. How do we find the other one? Plug it in. Which one do you want to plug it into? Bottom one looks good. So let's rewrite the bottom one. 3m, I want to put parentheses, plus 2p equals 24. That's what it says right here. 3m plus 2p equals 24. And of course, instead of m, I put parentheses. Why? Because I know that m is 6, and that 6 is going to go right in there. So let's plug it in. There it is. Let's do the math. 3 times 6 is 18, plus 2p equals 24. So we need to get rid of that 18 by subtracting 18 and subtracting 18. So I will have 2p equals 6. And the final step will be to divide by 2, which means p equals 3. Thank you. So we have the two answers here. Let's write it as a coordinate for a solution. So remember, m comes before p, so we're going to put that 6 first and that 3 second. There's your ordered pair. There's your answer, 6, 3. If you were to have graphed these guys, they would intersect at the location 6, 3. Let's move on to systems of inequalities. Now, a system of inequalities, the only way to solve it is to graph it and also shade. That way you show where your overlap is. So let's take a look at the first one, and I'm going to use different colored pens here. This first one, I'm going to graph it in red. And it is in y equals mx plus b form, where the m is the slope, which is rise over run. And of course, if the rise, if it's positive, it's going to go up. If it's negative, it's going to go down. So the rise, it could be going up if it's positive, and it could be going down if it's negative. And the run, you always look at it from left to right. You always want it to be positive, the run. Okay. So again, it is a fraction. Let me box in rise over run. And the b value, well, that's simply your y-intercept, which simply means where your line will cross the y-axis. So again, if you forgot this stuff, you start by looking at your y-intercept value. So it's 2. Right here, the b value is 2, the y-intercept's 2. So let's go to the y-axis. Let's go to the value of 2 on the y-axis. And let's put a dot right there. There it is. You see, we know it crosses right here. The line might be really steep going down, crossing through there. It might be really steep going up. It might be just kind of steep going up. It might be kind of steep going down, right? It depends on the steepness. And how do you tell the steepness? It's slope. So the slope is rise over run. You want it to look like a fraction. So whatever number's in front of x, that's your slope. What number's in front of x? A negative 1, right? And of course, we want it to look like a fraction. So you could put the negative 1, you could put it over 1. That way you know that from this point, since it's negative, you're not going up. Negative is going down. Okay? It's positive to go to heaven, negative to go to hell. Anyways, negative, you go down, right? So you're going down 1 over 1, you put a dot right there. And you could continue with that pattern of down 1 over 1, down 1 over 1, down 1 over 1. You could even use that same pattern backwards this way. So we make the line as long as we want, stretching from one side of the graph to the other. Now after that, we need to shade in, we first need to decide whether this line is solid or dotted. What do you guys say? Is it solid or is it dotted? Solid. Solid. Once again, if it has a solid line underneath your inequality, it will be a solid line. If it does not have a solid line underneath your inequality, it has to stay dotted. There we go. So let's make this solid. This one takes a while to explain. Once you guys already understand it, it'll be easier. Now we still need a shade. Okay, we still need a shade. See, the thing with inequalities, it's always talking about an area of answers, not just one answer. So the answers are either on this side or on this side. So how do we determine that? Plugging in a point and checking if it works. If you test the point 0, 0, and it does work, you're going to shade in this side. If you test the point 0, 0 and it does not work, that means it's not an answer. That means that all the answers must be on the other side. Or you could do the shortcut also. Check out the shortcut, guys. What does this say? What does that say? Less than. Less than, right? Or equal to. Now, what does less than mean? Above or below? Below. So you would shade in the bottom part. Pretty cool shortcut. I mean, but it would be nice. The better understanding of it is to test 0, 0. And when you say, okay, 0 instead of y is less than or equal to negative 0 plus 2, testing the top one, it'll say 0 is less than or equal to 2. which is true, which means that this point does work, so all the points down here work. Again, the shortcut, this says less than, and we know that less than means below. If it would say greater than, it would mean above. So above, we'd shade in the top part of it. Below, you shade in the bottom part of it. So if you want to save some time, you could go with that shortcut, shade below. Now notice, I'm not going to really darken it in. I'm just going to draw some lines like this. I'll really shade in the overlap piece because that's our answer. So let's go for the other one in blue. The other one crosses the y-axis where? -4. Let's put a dot at -4. It's kind of rough because you have to ignore what you already graphed, pretend it's blank. And then from there, what's my rise over run? Yep, the slope is 2, and you put it over 1. That way you could see that from this point, you go up 2 and over 1, and you put a dot right here. So I could continue with that pattern of up 1 over 2, up 1 over 2. Up 2 over 1. Reading it backwards. Up 2 over 1. And we have the line going all the way across. Now, is this going to be a solid line or a dotted line? Dotted, thank you. So let's just put some dots between the dots. And now we either shade in the upper part of this blue line or the lower part of this blue line. So what do you guys think? Do I shade in this upper part or the lower part? With the shortcut, upper, right? Greater than is above. So let's shade in the upper part of it, okay? So I want to shade in the top part. Now remember, the overlap piece is what really matters. So where on this graph do you see both the red lines and the blue lines? On this piece right here. So I want to really shade this in with a different color. So what's important about this when you look at it on the multiple choice is that this piece of it is solid, this piece of it over here is dotted, and this part of it is shaded. Moving on, number 4. The sum of two numbers is 31 and their difference is 7. What are the numbers? This will be on the midterm, almost identical to this. So we need to know how to first set up this system. Okay, what does sum mean? Add, the addition, right? So I have the sum of two numbers. Do I know the two numbers? So what am I going to call them if I don't know them?
Variables.
Okay, and what kind of variables?
X and Y.
X and Y. So the sum of two numbers, if I add certain number x plus a certain number y, and then it says is 31. What does is mean? Equals. Okay, so x plus y equals 31. And their difference, so this other part, and this is going to be a different equation right here. And their difference is 7. Divide. If I said, what's the difference between your age and her age if you're 14 and she's 13? Or something like that. What's the difference? 1. And how did you divide? You subtracted, right? So difference means subtraction, right? If I'm 6'3" and somebody else is 6'1", we say, what's the difference in our heights? Oh, 2 inches. Because you subtract, right? So difference means subtraction. Let's make an equation with those same two numbers that if we subtract them, their answer is 7. So x minus y equals 7. That's the difference of those same two numbers being 7. Does that make sense? So now that we have the system, we created one equation from the sum of two numbers being 31, and we created another equation because of the difference of their numbers is 7. The difference of those numbers is 7. So now that we have that system, we're going to solve it, and it's linear combinations, but it's already ready to combine and cancel, to eliminate. So the y's totally cancel out, and you have x plus x, which is 2x, and you have 31 plus 7, which is 38. So you have that simple equation that we need to solve. What do I do? There you go. So we have an answer, x equals 19. That is one answer. We need the other. We simply plug it in to any original equation. What do you guys want, the red one or the blue one? Blue one, sure, why not? So we have x minus y equals 7. X minus y equals 7. Why did I put parentheses on the x? Because I'm plugging in 19 right in there. Now notice that there's nothing to multiply the 19 by, so it's just simply 19 minus y equals 7. Let me just rewrite it. 19 minus y equals 7. So let's get rid of that 19 by subtracting 19, and I will have negative y equals negative 12. Let me rewrite that. Negative y equals negative 12. So what's our final answer going to be? Y equals positive 12. Because if you divide by negative 1 and you divide by negative 1, it becomes positive. So there's your answer. X equals 19, y equals 12. And right here, it's not really asking in the form of a coordinate. They're actually asking what are the numbers. So what are the two numbers? 19 and 12. Let's move on, number 5. And this one is a system by graphing. And I gave you 2 examples. There's only going to be 1 question, but I gave you both the examples here. So once again, they want you to graph on the multiple choice answers. Just going to give you a bunch of graphs. And what you could do on those multiple choice answers is check the point of intersection, and those are the solutions. So if you plug those into the system, you could double check by just looking at the point of intersection. But right here, we're going to practice graphing with different colors. I'm going to go with this first equation in red. And how do I start graphing this y equals mx plus b equation? How do I start graphing it? By looking at the slope or by looking at the y-intercept? Y-intercept. You always start with the y-intercept. Y-intercept is 1, the b value. So you put a dot right there at 1, Eddie. Now from that point, you got to look at your slope. What's the slope, Eddie? Negative 3. So if you want it in the form of a fraction, you're going to put negative 3 over 1. So from this point, since it's negative, am I going up 3 or down 3? Down 3. If it's negative, it goes down. So 1, 2, 3. And then over 1, you put a dot right here. You always go over to the right. You always run to the right. So we're going to put a dot right there. I went down 3 over 1. Let me go down 3 again and over 1. And I could go backwards to extend the line in the opposite direction. Now, this is not about solid or dotted. This is just a linear equation. So we're going to draw the line. Put some arrows on it. Let's graph the other one in blue. Is it ready to graph? No, it's not. What do I need to do in order for it to be ready to graph? Divide by 2, divide by 2, divide by 2. Y is going to equal negative 3x plus 2. So this one crosses at 2, and you go down 3 over 1, and you go down 3 over 1, and backwards up 3 over 1. Now notice, if I'm looking for the point of intersection, do these ever cross? No. As a matter of fact, you could even, once you get to here, you could see that this slope is negative 3 and that slope's negative 3. You know that they're parallel because they have different y-intercepts. So if they're parallel, they never cross, which means that there is no solution. So 5a, you could put that, or you could put no solution. It'll be typed in for you, obviously, on the multiple choice. Let's look at 5b. The top equation, I'm going to go in red. It is ready to graph, 5b. Where does it cross the y-axis? Negative 3. Okay, so let's put the dot at negative 3. From that point, what do I do? Up 1, right 3. Thank you very much. So if I go up 1, right 3, I'll end up right here. Now, if I go up 1 and right 3, I'll be off the graph. But if I go backwards, I'll extend it the other way. Down 1 over 3. And I already know that that's my line. Whoops, that was kind of off. I'm sorry. Now, the other one's not ready to graph, so let's get it ready to graph. What do I need to do to get it ready to graph? I either need to get y by itself, or I could find the x and y intercepts. How do you find the x-intercept? You set y equal to 0, and then how do you find the y-intercept? You set x equal to 0, and you could graph it that way. I'm going to go through and get y by itself. So I'm going to go plus 2x plus 2x. It'll be 6y equals 2x minus 18. And then I'm going to divide by what? 6. So I'm going to divide by 6, divide by 6, divide by 6, cancels. Y equals, I reduce 1 over 3x, and then negative 18 divided by 6 is negative 3. So right here, it crosses at negative 3. And I also go up 1 over 3. And I also go up 1 over 3. So what happens here, guys? They overlap. It's the same exact equation. So if I look at that original one, y equals 1/3 x minus 3, and I look at the new one that I just modified, it's also y equals 1/3 x minus 3. It's the same line. So if I'm asking what point is in common, what point's in common? All of them. So you say all real numbers. So on this one, you would say x equals all real numbers. Or, you know what? The better answer would be infinitely many solutions. You guys remember that?
Yes.
Infinitely many solutions. IMS. And I believe that's what they use on the multiple choice test. Infinitely many solutions. So if they're parallel, they never cross, it's no solution. If they're the same line, you say infinitely many solutions. And that's about it. Okay, so that was all on systems. I think there's one more on systems, but I'll pick that up on a different video.